Heat flux reporting is an important post-processing operation for heat transfer calculations because it allows you to compute an energy balance over all of the boundaries of the computational domain. In the Flux Reports panel, there's two options to report heat fluxes. The total heat transfer rate, which we see here, includes both the convective and the radiative flux, and it should generally be equal to 0 when the solution is converged, unless there's any external energy sources, such as from UDFs or UINTER in the cell zone conditions panel. In the case where there's sources, then the net balance here should be equal and opposite to the sum of all the sources that have been defined. The other option, radiation heat transfer rate, only shows you the net radiative flux, and generally the sum of this does not have to be equal to 0. It could represent, for instance, the amount of energy that's absorbed by the media. Compared to problems without heat transfer, additional care sometimes needs to be taken when evaluating whether the solution's converged. Firstly, the double precision solver is usually needed, and that's especially true in problems where you're solving for conjugate heat transfer. You want to make sure that you've allowed enough solution iterations not only for the residuals to fall below a certain level, but also to ensure that important solution variables that you've monitored no longer change as you perform more iterations, and that the net energy imbalance is small compared to the throughput. If you see that the residuals have reached a convergence criteria before the solution monitors level out, or the net imbalance is small enough, then you want to change the criteria to make it stricter and continue iterating until you achieve an acceptable energy imbalance.